Now that we have a nice conceptual idea behind these confidence intervals, let's walk through the process of actually creating one. So we're going back to this slide here. It's going to involve 5 steps, right? Determine the confidence level, which will lead to an alpha value and eventually the critical value we need for that margin of error. Once we have the margin of error, once we have our critical value, we'll compute that margin of error, which again is going to involve our critical value, our population standard deviation, and then the square root of our sample size. And then finally, we put together the confidence interval by using x bar as the center of our confidence interval and moving to the left E units and to the right E units, right? So we're just going to jump that margin of error in either direction. So if we go to our W10 D1 Excel sheet and we go to example 1, we'll see the same situation set up as in the slides, right? So we're creating a simple random sample of 50 people from Massachusetts. Now I've broken this up into different sections. We've got sample information, population information, critical value work, right? How we're going to get Z alpha, margin of error, and then our final answer really here is our confidence interval. So this is what we're working towards. So let's start with just the information about the sample. So this is only the information provided for our actual sample. So first of all, x bar, which we know is the sample mean, is 63,500. And our sample size is 50. And this comes from reading this particular piece of information. So this is our sample information here. We assume the standard deviation of income across all of our Massachusetts residents is 14,000. So this is population level information. This is what we would refer to as sigma. So this is 14,000. Now, the critical value work comes entirely from the confidence level that we're setting, right? Remember, the confidence level is just our fancy way of saying how successful should this confidence interval process be. So highlighting that we want to be 96% successful. In other words, we want to be 96% sure that the random sample we collect leads to a confidence interval that intersects our population mean. So we set our confidence level to be 0.96. Now keep in mind that when we're doing those middle percents, and that's fundamentally what we're doing, alpha is just going to be the missing percent. So we have 96% for the middle. This leaves 4% for our alpha value. And one way of getting this is by subtracting the confidence level from 1. Make sure that you're dealing with decimals, not percentages. Now, keep in mind, we want to make sure that we take that missing percentage, that alpha value, and divide it over the 2 tails. Oh, I don't have the picture. Anyways, we're going to divide this over the 2 tails. Sorry. Take this alpha, divide it over 2. You can do this in your head, but maybe you don't want to, right? Excel is a great calculator, so you don't have to do this. And finally, remember that Z alpha over 2 is defined. We can insert a little comment for ourselves here. This is defined as the Z-score with a probability of 1 minus alpha over 2 to the left, all right? And the reason that we care about the area to the left is because we're going to get our answer out of this from the norm.s.inverse function. And all of our Excel functions work with left-hand areas. So leave yourself that little note. We'll use norm.s.inverse, and remember the area to the left of the score that we want is 1 minus alpha over 2. So I'm just going to do 1 minus and then a cell reference of my alpha over 2 value. Okay, so these should be positive values. Your critical values will be positive, and they're typically somewhere between 1.5 and 2.5 for most confidence levels that would be worth setting. All right, so finally, our margin of error, we can again leave ourselves a little comment. Margin of error, E is going to be Z alpha over 2 times sigma over square root of our sample size. So notice we have all the parts for our margin of error in the different components. We've got z alpha over 2, we've got sigma, we've got our n. So we just have to do a bunch of cell references to make this computation complete. So z alpha over 2 times sigma divided by the square root of our sample size. This is the margin of error. This is how far we want to widen our point estimate into a confidence interval. We're going to move roughly 4,000 away from our best guess, which is x bar. So to determine our confidence interval, we're going to take our sample mean, and we're going to subtract this margin of error, and that will be the left-hand part of our x bar. And then we're going to take this sample mean and add our margin of error, and that'll be the right-hand end of our x bar. Or sorry, the right-hand part of our confidence interval. All right, so here's our concluding statement. We can be 96% confident that our sample mean, 63,500, leads to a confidence interval that contains the true population mean of residents in Massachusetts. And this, of course, I mean the mean income. All right, so in other words, this is how we would usually say it, we are 96% confident that the population mean income for residents of Massachusetts falls between 59,433, I'm rounding here, and 67,566. Let's consider example 2. Suppose we collect data on the weekly expenses for 60 randomly selected companies in New England. The mean company expense for this sample of 60 was 2,500. We assume the standard deviation of expenses across all companies in New England is 520. Assuming a confidence level of 95%, construct a confidence interval to estimate the mean expense for all companies. If we go to the example 2 worksheet in our W10 D1 workbook, we see the same problem. And again, what we want to do here is parse through sentence by sentence and think about the information each sentence gives us. So if we break this up, suppose we collect data on the weekly expenses for 60 randomly selected companies in New England. Which piece of information do you think this will be? Take a look at your options, pause the video and give it a shot. If you guessed n is equal to 60, that's correct. In our next sentence, the mean company expense for this sample of 60 companies was 2,500. Do the same thing, pause the video, look at your Excel sheet, and think about which one of these values that we're looking for is provided. All right, good. So hopefully you have x bar being 2,500. In our next sentence, we assume the standard deviation of expenses across all companies of New England is 520. Same deal, pause the video, see if you can correctly place that piece of information. Good. Now, sigma, remember, is a population parameter, so it's very important in the phrasing of this that we're talking about all companies. The assumption here is that this is for all companies in Massachusetts. That's why we can label this as sigma. This is the population level measure of variation. Okay, in our last sentence, we're told only one other piece of information, the confidence level, and this is the starting point for us determining our critical value, z alpha over 2. So we want a confidence level of 0.95. We can go through the rest of the computations. Again, I recommend you pause the video and try these on your own. All right, so remember alpha is the missing percentage, so if we subtract 0.95 from 1, we'll get 5%, which should go into the tails. We have 2 tails in our middle 95%, so we're going to divide that in half. And then finally, our z alpha over 2 comes from finding the z-score with 1 minus alpha over 2 to its left. So we'll use a norm.s.inverse command, and then do 1 minus the alpha over 2 value we computed previously. So this is our critical value, z alpha over 2. Remembering our formula for the margin of error, this is going to be our critical value, z alpha over 2, times the population standard deviation. But since we're working with the variation in the sampling distribution, remember we have to apply our central limit theorem. So we have to divide by the square root of our sample size in order for this last component to be the standard deviation that we really want to work with. So it's z alpha over 2 times sigma over the square root of n. This is the margin of error. This is how far we want to widen our confidence interval in order to increase the likelihood of us capturing that population mean. So what we're going to do is think of x bar as being our best guess for what the population mean is, and then we're just going to add and subtract 131 on either end to widen out to an interval. And this will increase the likelihood that we actually catch that population mean. So we're going to start with our point estimate, x bar. This is our best guess. And to get the lower value, we're just going to subtract our margin of error. It's easier just to do this with a cell reference. For the upper limit of our confidence interval, we start in the middle. We start at x bar, our best guess, and then we add, in this case, the margin of error. So these two values, we can be 95% confident that the true population mean expense falls between these two values. And that's how we would write our summary sentence. We can be 95% confident that the population mean expense for all companies, right? This is a population level estimate for all companies, falls between, and again, I'm going to round here, 2,368 and 2,630, let's call it 2 if we round up.